Okay, all right. Okay, first example I want to do today. Sine. Okay, let's say this is the problem that we're doing today. 330, sorry, not 310, 330. 330, make sure that's the correct number that you're using. All right, here's the numbers that the book will do. A couple of the problems they're going to give you right away, they'll actually already have them split up for you, so they don't give you the option of like trying to guess numbers yourself. If you want to know what the actual problem was originally, it was sine of 280, 285. This is the original number, and then you had to think of numbers that either added or subtracted. They didn't give you the option, they just told you that it was going to be 330 minus 45. And what we're going to do today is this problem is the one I would like you to put next to sine alpha minus beta. This is the example. So if you open up that second little pamphlet, this is the example that should be sitting there. We're subtracting angles today. Now, on the inside, the formula that you should have next to this thing is you have sine of the first angle, cosine of the second, and then we're going to be subtracting. So this is how it works. The example I want, sine of 330 times cosine of the second angle minus, or subtracting, sine of the second times cosine of the first. Okay, these are the ways that I want you to try to attempt your problem today. So you're taking the problem they give you, you're breaking it down further, and then we're going to use the unit circle to actually rattle off my answers. Is there any questions with the setup to this problem right now?
No.
Okay. So when you look at your triangles, or you look at your unit circle, we can rattle off our answers here for sine of 330. So if you look at 330 on your property sheet, it should say -half next to the sine of 330. So 330, the sine is the second answer. Cosine would be √2/2. Sine of 45 is √2/2 on your property sheet. And then cosine of 30 should be √3/2. And I believe it's positive on that property sheet. Again, use your unit circle, look those numbers up, and rattle those off. Okay?
What's the first one say?
That?
Yeah.
-half.
Oh, okay.
We're good? Okay. All right. Next step, actually multiply the two fractions together, so I get -√2/4. Multiplying the two back here, that's -√6/4. Then your last step is to actually attempt to subtract the two fractions, which you really can't. But my final answer on this problem is going to be this. -√2 minus √6 all over 4. And I said, every time you do these problems, the answers kind of all look the same. There's plus and minus signs, the order's different. Whatever you get, that's what you have. Questions on the first one? Are we comfortable with that problem? Yeah?
Yes.
Okay. All right, next one. All right, next one here. Cosine 165. Okay, a couple different ways we can do this problem. I'm going to try to give you an example of using the subtraction formula for cosine. I'm going to try to give you that example. So hopefully this makes sense to you. So cosine 165. I need to figure out numbers that subtract because we need that. So this is going to be the one that we're going to use next to the cosine alpha minus beta formula on your property sheet. So if you open up that little tab, this example I'd like you to put in there. The numbers I'm going to use on my particular problem, I'm going to use cosine of 210 minus 45. That's the numbers I'm going to use. Okay, we good so far?
Yeah.
All right, actually plugging the numbers in, here's what we have. we have cosine of 210, cosine 45, plus, because again, on the cosine formula there is a plus sign, it's the opposite of what you think it would be, plus sine of the first, sine of the second. Because remember, cosine kind of has a goofy formula about it, that it's using the plus inside the formula even though the numbers you originally picked were subtracting. We showed that last Friday's video, we showed how they derive these formulas, so hopefully that makes sense to you. We good so far? Alright, last thing, rattle off the answers from your unit circles. So if we look at 210, and you rattle off the answer for cosine, that should be negative root 3 over 2. If you look at your unit circle, you got to find 210. The cosine is the first answer. It should be negative root 3 over 2. Cosine of 45 is root 2 over 2. Sine of 210, that should be 1/2, and that's negative. And then sine of 45 is root 2 over 2. Again, correct me if my numbers, my fractions are wrong from the unit circle. I think those are right. That's what I remember anyway. Last step, we multiply them together, we add and subtract. Again, my answers all look kind of the same. It's kind of weird how these always work. All the answers are like some form of this when you do cosines and sines. It's just kind of weird how it always works. But anyways, this is going to turn out to be negative root 6 over 4 plus a negative root 2 over 4. So if I actually add and subtract straight across, you actually get the same answer as the last one I just did. They're just in a different order. This is actually the exact same answer anyway. Just different order.
I thought wasn't the 6 positive in the last one?
It was negative when you subtract.
Oh.
What's 285 plus 165?
110? 120?
I mean like 165 plus 285.
Oh, I don't know. Huge. I don't know.
What did you do?
A subtraction. 285 minus 165?
No.
Oh, geez.
Addition.
285 plus 165? 450? Okay. Okay, are we good with the 2 examples I've done today?
Yep.
Okay, the last one. Now, I'm going to get rid of all this if you guys are good. We have to do a tangent problem. Tangent's going to be tough. This is going to be a tough one. But I want to make sure we're good before I start here today. Anyone still need the 2 examples though?
Oh, you can just do this one on the far right board.
Actually, not a bad idea. Let's do that. Let me move the camera though.
I know, but
Perfect. All right. Okay. All right. The example I want to cover right now. Let's try to do one where we're going to get weird numbers like we did last time. I don't want to get like undefined. I actually want to do a real number. So let's do something like. Let's go with 2. Let's go tangent of 255. Tangent of 255 degrees. I want to talk about how this one works. Oh wait, we got to do subtraction though, don't we?
Yeah. You can't do 210 and 45 and we get a different one. It's not gonna work.
No, no. I got to make sure I'm doing subtraction. I almost did an addition from. Yeah, let's do. Okay. Hey, here's a new problem I want to do. We have to make sure that we're doing a subtraction problem, and I want to make sure we're getting the right numbers here. All right. Here's the example I want to cover. It's going to be a tangent subtraction problem. So if you're on that last tab we did yesterday, this is going to be tangent of, and the numbers I used was 240 minus 45. Okay, so we're subtracting 2 angles to make the 195 on the inside. Now the formula for tangent is kind of a lengthy one. it's a fraction, and we're gonna have to figure out what the numbers are without using the unit circle. So here's the formula you should have. Tangent of the first, subtracting the tangent of the second, all over 1 plus, and again that symbol changes depending on what the top one is. So if the top one's a subtraction, the bottom one's a plus. If the top's plus, then it's minus on the bottom. It's all depending on what this original one is. The original one will tell you what this top symbol is going to be. Tangent of the first times tangent of the second. All right, now, on this part, this is the part where, I think I already got them for you.
Yeah, you did. I was just gonna ask you a question. Where'd you get your kids' coat at?
My kid's coat, the red one?
Yeah.
I don't know, Target, something like that?
Cute.
Thanks. All right. Okay. First and foremost here, on this particular problem, we should get weird numbers. It shouldn't give me the undefined thing again, so we're gonna actually have to do reciprocal in this particular problem. I need to figure out what the answers are for each of these separately, and that's where you cannot use the unit circle, because the unit circle won't give you tangent. So this is where we're gonna have to rely on these triangles in whatever quadrant we're in. Now the beauty of this is, what quadrant is our 240? What quadrant is that in? What quadrant is 240 in?
The third.
Third. Tangent's positive in the third. So that's perfect. We don't have to worry about negative signs at all. And then the
All
tangent of
positive.
45 is in the first,
All positive.
so that's positive too. So I'm expecting an answer here, initially I'm expecting an answer that's positive when I plug these in, but I know the overall answer is going to be positive as well because of what 195 is sitting in. It's in the third quadrant, 195. So I know my final answer is even positive. So that's something that I should be thinking about. But anyways, here we go. Okay. Here's my two triangles. 240. 240 degrees is in the third quadrant. It's a 60-degree angle, and we're trying to find the tangent of 60. That's what 240 is. Again, how I'm doing that so quick, I'm using a reference angle in that third quadrant. I'm bringing this back to 180. So the difference between 180 and 240 is 60, so I'm doing a 60-degree angle. So tangent of 60 is opposite over the adjacent. So opposite of 60 over the adjacent of 60 is root 3. So the top of this is root 3 over 1, which I'm not even going to put it over 1. Tangent of 45, opposite over adjacent. Well, that's going to be 1.
Wait, can you tell me how you got the tangent of 240 again?
Tangent of 240. The 240 itself is a 60-degree angle. Because if you're in the third quadrant of 240, you subtract it back to 180, and it's 60 degrees. So then you just rattle off tangent of 60.
Okay,
But again, it's root 3 over 1. Tangent of 45 is 1 over 1, so I just leave the ones off the bottoms. Then on the bottom, I have 1 plus. Tangent of 240, I already did it. That's root 3. Tangent of 45 is 1. And my final answer, which if I were to multiply these together, this is what I want you to leave your answer as. Root 3 minus 1 over 1 plus root 3. This is what I want you to leave it as. I know that you would have to rationalize it, get rid of the radicals off the bottom. I'm not worried about that today. The fact that it's not complex, and I don't have fractions over fractions, I don't need to do reciprocals at all. Tangent, usually when we do these tangents, answers will always look some form of that. They'll have plus and minus signs in different spots. But that's kind of what I would be expecting. Understand what tangents are roughly going to look like. Now again, on like a calc level course, they would have you rationalize that. You'd have to get rid of the radical off the bottom by using a conjugate rule. That's something we'll do later. I'm not worried about it right now. Okay? We good? Homework. I'm going to put it back on the board that we had yesterday. Okay, here's the problems. You have the rest of class day, which is about a half an hour. Kind of work. Alright. Let's see. I don't know if I want to get rid of anything on the board here. I'm just going to get rid of the special triangle.
Me today.
Okay, here we go.
You went a Friday this.
Oh, you did that? Yeah. Like, I came to
Okay, hey, page 603, 2, 7, 17, 18. Then jumping to 14, 26, 30, 28, 22. Okay, this is the order that I'd like you to actually attempt these problems. Go in that order. It's going to go cosines, sines, tangents, kind of in the order. Use your property sheets, figure it out. And use that little handout that we created. That will help you out to figure out what your formulas are.
I didn't use on that.
Some of the problems are already split up. You just have to rattle off the answers. It's kind of nice. Oh yeah, that looks good. Thank you, Josie. Good work.